In this lecture, we're going to see how we can pass arrays as function parameters. And let's look at an example to really drive the point home. Here we have a function called sum. It's going to take an array as the first parameter, and it's going to take a second parameter, which is going to be how many elements we have in the array. And we have to do that because once we hit the body of the function, we have no way of querying the size of the array from this array parameter here. So we have to pass the count as a second parameter. And once we do that, we can go inside the array and do whatever we want. In this case, we want to compute the sum of the elements we have in the array. And by the way, this is a double array, so the elements are of double type. Down here, you see that we can modify the data in the array. We can do this because this is not an array of const double. And down here, I want to drive the point home that once you pass an array as a parameter like this, the array variable name is going to decay into a pointer. So down here, if we try and print the size of the array, we're going to get the size of the pointer printed out. Because the guy on the top here is no longer a full array, it has decayed into a pointer. So if we print the size, we're going to get the size of a pointer, and we can prove this by seeing that it is the same as printing the size of int pointer or long int pointer. By now you should remember that all pointers on the system are going to have the same size regardless of what the pointer is pointing to. Okay, because the array variable name here has decayed into a pointer, we can't really use std size to deduce the size of the array. Because once it becomes a pointer, it no longer has the information required to compute the size of the array. We have seen something like this before. So now that you know these little details, we can go down here and loop through the array and do our sum. We're going to use a for loop in this case, but you can use any kind of loop, whatever makes your life easier. We're going to say for size ti, I is going to be initialized to 0. We're going to loop until I is no longer less than count, and count is going to be the number of elements in our array. Once we hit the body of the loop, we can use pointer arithmetic syntax like you see here. We can go through the array index, or we can go through pointer arithmetic by incrementing like we do here. You can use whatever you want. All these things are going to compute the sum. At each iteration, we're going to grab the element at that iteration and add that to sum. And when the loop is done, we're going to have our sum stored in this sum variable here, and we're going to return it to whoever called this function here. Again, the main message here is the syntax we use to pass arrays as parameters to functions. It is the syntax here. When you do something like this, the array name here is no longer a true array. It's going to decay into a pointer, and it's basically going to be the same as passing a double pointer like we do in this line that is commented out here. Okay, now that we have our function set up and the function is going to take an array as a parameter, let's look at how we can call this function. Here we are just setting up a simple double array. It's going to contain 10 elements, I guess. 1 through 1, 2, 3, 4, 5. That's 5 elements. And we're going to call the sum function. The first parameter is going to be our array. That's how we pass it. We pass the name of the array, and we pass however many elements we have in the array. And we're going to store the sum and this total variable, and we can do whatever we want with this guy here. For example, here we are printing it out. Now that we have seen this, I think it is time we headed over to Visual Studio Code and played with this a little more. Okay, here we are in our working folder. The current project is array function parameters 1713 here. We are going to grab our template files and put them in place. Let's do that. And we are going to open this in Visual Studio Code. Let's do that. We're going to open 1713. We are going to open our main CPP file, and we are going to set up our function here. The function is going to return double, so let's do that. And it is going to be called sum because it's going to compute the sum of an array. And we are going to pass in a double array. And by the way, you don't have to call this array. This is just because it is an array. But to remove any confusion, let's call this scores. it's an array of double that is called scores. And we denote that this is an array parameter by putting angle brackets after the array name here. After that, we need to specify the number of elements in our array as a second parameter. Let's say that. Inside, we're going to set up a simple variable which is going to store our sum. It's going to be a double variable. And let's call this score sum. Why not? And it's going to be initialized to 0 through a braced initializer like we do here. The first thing I want you to see is that once we have a syntax like this, the array name here can no longer be used as a regular array because it has decayed into a pointer. And I wanted to prove that to you. So if it is a regular array, for example, if we go in main here and set up an array, let's say double scores, let's say my scores, and it's going to be an array of double. We're going to initialize this, and let's put in 10.5 and 3 or 34.2. And if we go down here and say stdcl size of my scores and print this out, this is going to print the size of the entire array. So we have two doubles inside. We're going to have the size of two doubles for all this array here. This is a property that the array name has. You can go through that and deduce the entire size of the array. Let's try and run this program. You're going to see this in action. We are going to build with GCC. And here you see that we have a warning saying the function is not returning anything. This is a function returning void, but we're not returning anything. I don't like this warning, so let's just return score sum for the moment and build again and get rid of this warning. So our build is going to be good. And let's bring up a terminal and clear. And if we run Rooster, we're going to see that the size of my scores is 16 because we have two elements in here. But we can't do that in our function here. Let's see what we get if we try to get the size of scores here. We are going to say stdcl size of scores, and we're going to do that size of scores. And for this function to run and give us something to see on the terminal, we need to call it. We are going to call it with this array here. We can do that. So we can call our sum function. We're going to give it the array name, my scores, and we're going to say how many elements we have in the array. And we can do that. We can tell it we have two elements in here. So once we call this function, this line is going to run in the body of the function, and we're going to see the size of this array here. At least we hope. Let's try and build. We're going to build with GCC. The build is good, but you see that we have a warning here. The compiler is nice enough to try and warn us about the problem we're going to have here. Size of scores is going to return the size of a double pointer. That's what we have here. And the size of a double pointer is whatever size our pointers are going to have on this machine. So the build was finished, but with warning. So we have our binary, we can run it. Let's run Rooster, and we're going to see that size of scores is 8. Okay, that's the size of a pointer on my system. And it really doesn't matter how many elements we have in the array here. Let's put in a 4.8, a 6.5, and now we have 4 elements in here. But if we build again, we're going to see that the size of the array is not going to change. Okay, so we don't see the change here. Let's see, you see the size of scores is 8 because the size of this guy is the size of the pointer. The name of the array has essentially decayed into a pointer, and it's really like a pointer. If we go down here and try to print the size of int pointer, for example, that's what we're going to get. We're going to get an 8 because pointers on this system are 8 bytes. So let's do int pointer here, size of, not size t. Can't type and talk at the same time. Sorry for this. So we're going to do stdendl. And if we build again, we're going to see the size of our pointer to int printed down. So we're going to ignore the warning and run rooster, and you see that the size of a pointer is 8. So in these things, I am really trying to prove that when you pass an array like this, it's no longer an array, it's just a pointer. And hopefully you have seen that with these statements here. Another thing I want you to see is that because this is a decayed pointer, you can't really use it to deduce the size of the array. If you try to use std size with this and pass the name of the array, let's do that, and store this in a variable, let's say size t size or r size to say array size. And you notice that we don't have access to this guy because we don't have the header that brings this n included. If you don't know which header you should use to have access to std size, you can just come to your favorite search engine and search for this. You're going to get a link to CPP reference. We can go to that link, and we're going to see that there are a few headers we can include to get access to that guy, and array is one of those headers, so let's include that. We can head over back to our project and include array, and this squiggly line should go away by now because we should have access to that guy. It doesn't go away. Let's try and build with GCC. And this is going to give us a compiler error because our scores array here has decayed into a pointer. We can't really use this. If we do this, std size won't know how to deduce the size of the array from this pointer. I want to show you that this syntax with std size is going to work if we are using a regular array. So let's grab this line here and put that in our main function. And we're going to say std size my scores. That's what we're going to use. You're going to see that this is going to compile fine. And if we print our size, we're going to get however many elements we have in here. So let's do that. stdc out size. Let's say size. This is enough. And our size. And if we build this, we're going to get the build, which is successful. And if we go down here and run this, we're going to get the size to be 4 because we have 4 elements in this array here. So hopefully you understand that when you pass an array as a parameter, the array name is going to decay into a pointer. So don't try to use it like it is a regular array. Okay, now that this is out of the way, we can take all this crap out. And we can change this guy to use std size because I don't like hard-coded values in here. So we're going to say std size, and we're going to say my scores, and this is going to pass the size of our array dynamically. We don't want to change the call to the function whenever the size of this array here changes. Now that we have this, we can actually go inside and compute our sum. We're going to be looping around. We're going to say for size ti, and we're going to initialize this to 0 explicitly to make that super clear. We're going to be looping as long as I is less than count. And we're going to put in our incrementation part. Let's do that. We hit the body of the loop, and we're going to say sum, let's say plus equals, and we're going to say scores I. We can use that here, and it is not sum, it is score sum. And when we hit the end of the function, we're going to return whatever sum we have. So what we are basically going to do is to loop around adding to score sum. At the first iteration, we're going to grab the first element and add it. At the second iteration, we're going to grab the second element and add it. And at the end of this function here, we're going to have our sum stored in score sum here. Let's bring this up because it is ugly right now, and we can cramp all these lines together so that our function is not really ugly. And if we run this, we're going to have this function return our sum. We can grab the result of that in a variable. Let's do double and say result. And we're going to grab whatever was returned by this sum function here and store that in our result, and we can print it out. We can say stdc out. Okay, we have our code in place. We can build this and see what we get. The build is good, so we can clear and run rooster, and we see that the sum is 56.1 And if you add these guys up, I am sure you're going to get this. If you don't believe me, we can bring up a calculator and do the sum here. We're going to take 10.5, let's do that, plus 34.3 plus 4.8 plus 6.5. And if we do that, we're going to get 56.1, and it is what we have in our program here. And again, this is really meant to show you the syntax you use to pass arrays as function parameters and make you aware of what happens when you pass an array as a function argument like we do down here. This is the syntax we use to call our function with an array parameter. We just pass the array name, but once the function is called, we can't use our scores variable here as an array. It's going to decay into a pointer, and if you try to use size of on this guy, you're just going to get the size of the pointer, and you can't use std size on this guy because it's basically a pointer. So we can actually put in a syntax that is going to give this guy as a pointer. So we can comment that guy out and say double sum, and we can say double scores pointer and say size t count, and put in our opening curly brace here. This is a bad syntax. We should have double pointer and say scores here, and you're going to see that the squiggly line goes away, and if we try to build the program, it is going to work exactly the same. Okay, the build is good. We can clear and run Rooster, and we should get the same value here. This is really all we set out to do in this lecture, and again, the main message is to show you how you can pass arrays as function parameters and show you some problems you can come across if you do that. So you really need to be careful, and the main thing is that your array name is going to decay to a pointer, and you have to resort to passing the size of the array as a second parameter here, because we can't deduce the size of the array using any of the methods we have seen before. We can't use size of to get the size of the entire array. We can't use std size. This is the only way to get the size of the array. We have to pass it as a second parameter. We are going to stop here in this lecture. In the next one, we're going to see how we can pass sized arrays as function parameters. Go ahead and finish up here and meet me there.